Hey guys, okay, so you were doing a lab today on Continental Drift. So I'm going to give you the notes that go along with it. So Continental Drift, you've learned since elementary school. Okay, but now we're going to learn the history behind it a little bit. So the hypotenuse of Continental Drift is that, the continents were once joined together to form a single supercontinent known as Pangaea. Roughly 200 million years ago, all of that combined into that supercontinent. And in that 200 million years, it has slowly spread apart. Okay, the person who came up with this was Alfred Wegener. Okay, he is known for putting all of this together. He was a German scientist with a PhD in astronomy. Okay, and he was a professor of meteorology and geophysics at the University of Graz in Austria. So, needless to say, none of his degrees were in geology, were in studying the Earth in that aspect. It was more of the space and the weather and all of that. Okay, he did different expeditions in Greenland, 1906, 1912, 1930, looking for evidence to prove all of this. So, continental drift was an idea before its time. People weren't ready to think how that works. Okay? There was people who said Wegener's hypothesis in general was footloose, that it took a lot of liberty, that he made up a lot of things. So Wegener had to come up with proof. Okay, so there's 4 pieces of evidence. There's the continental puzzle, matching fossils, rock types, mountain ranges, and I'm going to say it wrong, glaciers, and there's one more that you're going to be learning about, which is seafloor spreading. Okay, seafloor spreading kind of pulls everything together and proves it for him. So if we look at the continental puzzle, you can see during Pangaea how everything was together and how it slowly spreads apart. It's like a puzzle you can put together. You can see what piece fits into what. Okay, and then we've got fossil evidence. Having the same fossils on South America as what you see in Africa proves that they were once close together for these animals to be able to be in both land masses. I mean, if you look, there are some that were in Africa, India, Antarctica, continents that are nowhere near each other now have the same fossils. Okay, so that is proving his theory of Pangaea, that everything was together. So I want you to think, how else would we have found fossils on those various continents unless they were joined at one time? Are land bridges something that could have happened? It would be very hard for that distance to have a land bridge. Swimming? Once again, that is a huge distance for them to be able to get there. And the wind, these things weigh too much for the wind to just blow. So I want you to look at the rock types and mountain ranges. Okay, there are mountain belts separated by oceans that share the same type of rock. If you match up the continent, you can see that they form a line. Okay, so think rock types. When they dig down and look, the edge of Greenland might have the same as the edge of Europe. North America might have some of the same as Africa. So just where they fit in, you're going to see very like objects and minerals and all of that. Okay, the Appalachian Mountains, British Isles, and the Caledonia Mountains are the same age with similar rocks and structures. So when you go through and you put everything back together like it was Pangaea, if you look at the bottom picture, you can see how it all lines up. It all lines up into a straight line, with them being the same age and similar rocks and structures, and being able to form that line. That helps prove Wegener's theory. Just another graphic to look at. Okay, so the word I can't say, galactation. Okay, so I want you to look. It's evidence for ancient glacial climates and land masses that are now located near the equator. So what they're doing is they have found like things in Antarctica, the southern part of Africa, the coast of South America, India, and on the coast of Australia that show at some point it was covered in ice with a glacier. It has the same characteristics, same minerals, same layers, all of that to prove that at one time they were all together. So it's deposits of the glacial till, which is your mix of sediment, clay, rocks, anything that's deposited by the glacier. Okay? As a supercontinent, South Africa was centered over the South Pole. Okay? That's why South Africa has such a ginormous portion that has this deposit. So I want you to think, what's the matter? Wegener's hypothesis was very scrutinized. Most geologists eventually dismissed Wegener's theory as a fairy tale. Okay? They said it wasn't adding up. So Wegener's missing piece, he could not explain the mechanism by which the continents moved, which we now know is convection currents. Okay? He believed the oceanic crust plowed through the continental crust like an icebreaker to a ship. But we know that now it's not true. Okay, so as he's still researching this to prove his theory, different confirming discoveries are starting to roll in that is starting to convince other scientists that these continents did indeed move. Okay, so in the 1950s, the discoveries of seafloor spreading and paleomagnetism supported Wegener's hypothesis. So what is seafloor spreading? That shows where magma from the mantle is coming up through that mid-ocean ridge. Okay, and as it comes up through that mid-ocean ridge and deposits, it's pushing older sand and stuff out, and the newest stuff is going to be by that ridge. Okay? And I know you have an activity you're doing today with this, and Friday. So it's going to make a lot more sense after you work through it. But I want you to think, by that magma coming up just at certain times, not all the times, it's giving you layers that you can age from, that you can see changes in, that you can see the flipping of the magnetic pole in. Okay? So as you get through, and I will do a short, sweet video on seafloor spreading later in the week. Okay? That was the seal. That's what brought everything together for Wegener and proved that Pangea did exist. Okay? Wegener discussed the convection currents as a possibility. So he didn't exactly know about them, but he had the idea already starting. So I want you to think, Wegener had 4 things that he had to have to prove. We had fossils. We had rocks and mountain ranges. What else? Give me a second to think. Some of the same plants. And his last thing they brought together, even after they looked at the glacier deposits, is the seafloor spreading. That's what proved continental drift happened. Okay? So, continental drift, it's a thing. And remember, Alfred Wegener. So, enjoy the lab. Let me know what you think.